Progress.
Okay, guys, today's lesson will be a probability theory lesson. We're going to try and do as much work as we can, but also we're going to try and explain probability from a grade 10 point. So we're going to start with everything. We're going to try and do it slowly, so it might be a very slow-paced lesson. But the word probability means chance. It doesn't really mean chance, but it's a chance something would happen. Now, in probability, we get a lot of events, but we also get a lot of experiments. And we need to know that an experiment is a word that refers to a very uncertain process. So when you see the word experiment, know that it's a process that's uncertain. We don't know what's going to happen. But we also get the word called outcome. Now, when you see the word outcome, you need to understand that it's an outcome of an experiment is it's a single result in the experiment. So it means if you flip a coin, it's gonna land on heads or tails. So the outcome would be the single result of the experiment. If you roll a dice or roll a die actually, and it lands on five, that would be the outcome. It's the single result of your experiment. And the experiment is uncertain because when you roll a dice or die or whatever you're rolling, it's fine. We don't know what number it's going to land on unless you guys are cheating. So there's a lot of things we can do. We could talk about experiment one. If by some chance we got a student on this call and they flipped a coin, and if you flip a coin, there's only two choices. Choice one is it's going to land on heads. Choice two is it's going to land on tails. It is uncertain. We don't know which one, but the outcome is whichever side it lands on. Same thing. We roll a dice, two dice, and we don't know what dice one and dice two is going to land on because it's an experiment. But the outcome is the answer that it goes on. And probably experiment three would be something like a cricket match. Two teams playing cricket. We are interested in the final score. The outcome would be who won the match and what the final score is. Example. Right? We get something called a sample space. So a sample space of an experiment is the set of all the outcomes of the experiment. So it's every outcome that's in the experiment. That's what a sample space is. Now, you guys, I'm gonna skip a lot of the work that we don't need because, to be honest, probability is it's quite a big section, and a lot of it comes out, but also a lot of it is skipped. So terminology, we need to know what an event is. An event is a specific set of outcomes of an experiment that you specifically are interested in. Okay, so you're gonna see the word event a lot, and it's important to understand what it is, but generally, this is all theory. It's just for you guys to understand. Again, probability. Probability has to be a real number, and it has to be between 0 and 1. Now, you guys are not in a primary school, but when I teach the grade 5s probability from private schools, probability starts at 0, it ends at 1. 1 is 100%. 0 is 0%, right? So 50, this could be 5 is 0.5 is 50%. And guys, this would be an even chance of happening. This would be certain, as in 100%, there's no chance it's not happening, and this would be impossible. Now, we can deal with stuff from 0.5 to 0. This would be less likely to happen. This would be unlikely. This would be likely, and it just moves on and on. Now, again, a probability has to be a real number, and it has to lie between 0 and 1. And it has to describe how likely an event would occur, right? Probability can be denoted in three ways. We can actually say probability in percentage. We can do probability in decimals, or we can do probability in fractions. Technically, all three is the same thing, but we just need to know. That probability, there's no wrong answer. It's either percentage if you want. I prefer decimals. It's easier to use, and I prefer fractions. That should be that should be technically all they use for this part. But let's go and talk about what theoretical probability means. This is really important. Okay. So we're going to talk about theoretical probabilities, and the theory part of this is it's quite, I would say, easy. Okay, theoretical probability is the chance that something would happen, right? It's the proper chance that something would happen. So let's go with if I flipped a coin, let's look at the total. Okay, let's take a dice. I think a dice is a good idea. Let's take one. Let's take two. Guys, I'm very bad at drawing. Three, four, five, and six. Okay. Theoretical probability says, what is the chance that something would happen over here? Definitely. So it's not the relative frequency. It's not the definite part. We'll do examples at a later stage. But theoretical probability states, what's the thing? So let's pick a random number. Let's pick 4. On a set, not a set, on one die. On one dice, there is only one 4. So the probability that I get a 4 is 1 out of, and the bottom number is the total chance, the total numbers they are. So it's 6. Or the total, let's say the total paths that can happen. But let's even pick something else, right? Because I use numbers and it's a problem. Let's pick colors. Let's pick blue. Let's pick green. Let's pick red. Let's pick yellow. Right, guys? The chance that I would get yellow in this draw would be 1, because there's only one yellow, over the total number of choices that I have, which is 4. If by some chance I had another yellow, I don't know why I have 2 yellows, but I do, the theoretical probability that I would get yellow from a draw would be 2 out of 5, because there's 2 yellows and the total number of choices is 5 choices. Okay? Now, this is theoretical probability. It doesn't always happen like that, because when you're playing a game and you need to roll a dice to 6, it doesn't always come. It doesn't feel like it comes once in 6 times, because you need a very, very big, you need to, if you want to test theoretical probability and match it to relative frequency, you need to at least test a lot of times. Rolling a dice 5 times or 6 times is never going to test that. Okay, guys. So the next step would be us doing a random question. So we'll keep all of the questions for another lesson. We'll do a teaching lesson for now, but let's do a very basic question just to see what happens, right? So you got this bag. I don't know why it looks like this, but you do have this bag. And in this bag, we have 1, 2, 3, 4, 5, 6. You got 6 marbles. I don't know why this person's carrying 6 marbles, but it is there. We got 3 blue marbles. We got 1, let's go with 1, or let's go with 2 green marbles. And let's go with 1 yellow marble. Okay. Now a ball or a marble is picked at random. Now theoretically, the probability that I can get red, the probability of red theoretically would be 1, 2, 3, 4, 5, 6, because there's 6 red marbles, and the total that's there is 10, 12, if I'm not mistaken. 6 out of 12. You can simplify this, which makes it 1 over 2. You can simplify to 0.5. You can simplify to 50%, but also it's up to you. The probability, I want you guys to understand this. The probability, theoretical probability for me to get a blue marble or a yellow marble. So it means I can get either blue or yellow. Now, theoretically, there's three blue and there's only one yellow. So 3 over 4, 3 plus 1 over 12 equals to 4 over 12. Now, I'm not going to simplify further. You guys can simplify. I just wanted to show you what the theoretical probability is. Now, this one is also important. The theoretical probability of getting not green. Now, this not sign is a bit annoying sometimes because sometimes you could see a small apostrophe like that. And this is not green. So not green means I just remove green and everything else is not green. So theoretically, the probability of not green is 10 over 12. Now this one is tricky. It is very, very tricky. But the probability, okay, the probability of not green, let's put it, I'm putting this apostrophe, not green or red. Now, what does it mean? Not green or not red. It means remove green or red. So when I remove green and red, it's technically the probability of yellow and blue. So we need to be able to look at probability in that way and understand it. So we know it's 3 plus 1 over 12, which is 4 over 12. And guys, the not becomes a little bit difficult, especially when you're dealing with difficult values and it's not put out in very simple grade 1 questions. But we go on with something like this. I got apples. I got bananas. I got 72. Okay, let's put easy numbers. 70 bananas and 30 apples. Right? The total is 100. Okay. Now, guys, if I only got apples and I only got bananas, and I tell you, listen, the probability of a banana would be 70 out of 100. The probability of an apple will be 30 out of 100. Okay? The probability of not a banana. Now, guys, if I want to talk about the probability of not a banana, I can see what's left over is 30. So the probability of not a banana is 30 out of 100. But now you can see that the probability of not B is technically the probability of A. This is complementary. We'll talk about that later. But we can calculate it very, very, very simply because there's a formula that I want you guys to start writing down. I know you guys are not writing notes at the moment, but please write down this formula just for now. Probability of not B is equal to 1 minus the probability of B. So what I'm trying to say is that if you want the probability of not B, you will just take 100% and you minus the probability of B, and you will get the answer. So the probability of not A will technically be B. Look at this. The probability of not A would be 70 out of 100 because the probability of not A means it falls on B. And that's all there is to this first part. Okay, so this was part 1. Part 2 is about us talking about relative frequency. Now, this part, we did do a few questions, and it was difficult at the start, but the relative frequency changes. So the relative frequency of the event is basically the number of times the event occurs. Now, what that means is the relative frequency is if I had dice, right? 1, 2, 3, 4, 5, and 6. I'd like you to understand that if I roll this dice, let's say 20 times. So we're rolling it 20 times. And out of the 20 times, I rolled 7 3s, right? So I rolled, let's do 3, and I rolled this 7 times. I'll put a table with this thing with a few examples so we can practice. But I rolled the 3 7 times. I want you to understand there's a difference between theoretical probability and relative frequency. I think the best way to do it is to use to actually use a question. I think the best way to do it is to actually use a question and a dice question as well. So we're going to use a question. Okay. I think questions like this is a little bit easier to deal with, especially to explain relative frequency so you guys can see what's actually happening. But let's take this experiment. A dice is thrown 24 times, and they want us to study the results before answering the questions before. So what's going to happen is the first thing I should do is draw a frequency table, right? You can draw a tally table, you can draw a frequency table, whatever works for you. Tallies should be taught in stats, but if you guys don't know, we'll cover it at a later point. This is the dice, and this is the frequency. Now, I'm going to skip answering. That's 1, 2, 3, 4, 5, 6. I've done this question multiple times, so I do have the answers. I'm not going to sit and count it for you guys because make things a bit untidy. But if you don't know, all we would do is go and count the number ones. 1, 2, 3, 4, and we write down the frequency as 4. And we will continue in that way until we get to 6. Now, I'd like right? So what would happen is we would count. Now, please make sure to add this total. Please make sure to try and get this total, and this total would be 24. If it's not 24, then something's wrong. Now, guys, the frequency table part was quite simple. That's okay. The dice, the frequency, the relative frequency, all of that's easy to deal with. What is the theoretical probability of rolling a 3? Now, this is where things change because I want you to, please don't draw dice and stuff in your exams. I want you to understand properly what this means. So we got this dice and there is only 6 numbers. That means the total is 6. It will never change. There's only 6 numbers on the dice, unless you got a dice that's cheating, but it's there. And there's only 1 3. So the theoretical probability of rolling a 3 is 1 out of 6 because there's only 1 3 and there's 6 chances. But what is the relative frequency? The relative frequency means, okay, the total number of times we did this experiment is 24. And the times that we rolled a 3 is 7. So it's 7 out of 24. What is the theoretical probability of rolling a 6? That's 1 out of 6. And what is the relative frequency of rolling a 6? And in this experiment, it was 2 over 24. We can see the theoretical probability is not changing because there's 1 of each thing. But later on, we can do experiments and we can do questions where there's more than 1. Okay? Now, let's go with the next one. What is the theoretical probability of rolling a 7? It is absolutely impossible to roll a 7. So it's 0. What is the theoretical probability or relative frequency of rolling a 7? It is 0 because they did not roll any 7. So now we notice that theoretical probability is a chance of something happening. Relative frequency is what really happened in the experiment. And the next two questions are theory questions. We'll come to do questions like this later on. But these are yes or no questions, and there's marks for both sides, as long as you give something that makes sense. Do you think the dice is loaded? I could say yes. I could say why. I could say yes because I could say, look at how many times the number 3 is rolled. It seems a bit unfair. I could say no. More realistically, no, because the experiment wasn't done so many times. It was only done 24 times. That's not enough times to get an accurate reading. Maybe they should have done it 200 times or 300 times, but for now, that's all there is for this part. Okay, so I think maybe one more question for relative frequency should be good. Yeah. And then we can move on. I am going to do the questions quite fast because I do have homework worksheets for you guys. So you can use that. Right, relative frequency in terms of this question. We did this question again as well. So it shouldn't be anything too difficult. But I'm sure we can answer this quite easily. Now, when it comes to the relative frequency, please understand that it is easy. It's nothing, but your questions will never be this easy in the exam. You just need to understand what happens, right? Firstly, okay, cool. So there's a Smarties factory and there's equal colors of red, blue, green, purple, orange, and brown are made. I apologize, I cut off the question. You open a box of Smarties and you find this the following quantities of each color. Okay. Now, how many Smarties should we expect to find in a box? Okay. Okay. So this question is quite simple, right? Let's start off with the numbers first. There's 1, 2, 3, 4, 5, 6. So the theoretical probability of this box of any color would be 1 out of 6. So if we're dealing with 1 out of 6, it's quite simple because how many, let's go with question A, how many red Smarties should we expect to find? Right? What do we expect to find? When they say expect to find, it's theoretical. Now, if we look at it, they told us the theoretical probability is 1 out of 6. So 1 out of 6 multiplied by the total, which is 144, and we should expect to find 24 red Smarties. But we don't find 24, and that's fine as well. What is the relative frequency? Now, this is a bit different because the relative frequency would be 19 out of 144. And this does not match up because we were supposed to find 24, but we only find 19. That's okay as well. If we go with how many brown Smarties should we expect? The word should we expect means theoretical, okay? In a box of 144. And this is the exact same thing. Theoretical probability, there's only one brown color out of 6 times 144, and that equals to 24 brown. Question D would definitely be, what is the relative frequency? That means how many brown Smarties do we actually get? 29 out of 144. Right? You guys can simplify that. I know the simplifying part is important, but I'm just trying to teach you guys for now. Let's go with the next one. Do you think the Smarties were mixed well before they were poured into the box? Guys, this is a yes or no question. It's up to you. I would say yes, because everything is generally around the 20s, 24. I mean, it's not perfect, but there's no outliers in stats. There's no outlier where one is in the 50s and one is in the 10s and one is in the 30s. It's generally mixed well. Okay. If you wanted a blue Smartie, right? What is the chance you would pull one out of the box? Now, this one is technically relative frequency. Do not confuse the two because they're not asking you the probability that's theoretical. They're telling you you're physically taking one out of the box. So what is the probability of a blue Smartie? The probability of a blue Smartie would be 23 out of 144. And if you wanted a yellow Smartie, the probability of you getting a yellow Smartie would be 0. The reason? There is no yellow Smarties in this box. But that's all there is to relative. Okay, guys, the next part of the lesson would be Venn diagrams. Now, when it comes to Venn diagrams generally, they are quite easy to deal with if you understand them properly. But if you don't, that's where the problem's going to come. So we're going to do a bit of theory. These are questions that's made up on the spot, so just bear with me. So a Venn diagram in general, let's go with something like this. Okay, so we're going to go with a Venn diagram and we're going to start trying to learn the probability of all of these random things. So I'm going to pick people that like, we're going to call this the people that like dogs, people like cats, and we're going to start to worry about. So in grade 10, you do 2 events. In grade 11 and 12, we do 3 events, okay? So the number that comes on the top, whether it's here or inside the box, is fine. There's no problem. I don't mind. It doesn't matter. It's what your teacher prefers that works. But this is the total people that took part in the survey, or the total people you interviewed, or the total people that was in this complete survey, right? So we're going to use 100 because it's easy numbers to deal with. We're going to start without doing level 4. We're going to start, let's put this as 50. Okay, no, that's unfair because I'm a dog person. That's going to be 30. That's going to be 20. That's going to be 10. I don't like cats. And that's going to be 30 plus 20. This is a very biased, this is very biased, guys. Just understand that. Let's make this 50. Right? Just understand it's biased. I made it up. But let's go here. Let's start to understand what happens now. This is the number of people that don't like anything in the survey. Okay? Don't like cats or dogs. But guys, don't memorize it as that. Memorize it as the bottom number is the people that's left out, the people that don't enjoy those options, the people that's not part of this options. Okay? The top is the total. And now we need to start talking about the different circles because there is 2 circles, but there's 3 parts. Firstly, this is the dog circle, the one that I'm about to highlight now. And you need to understand this is the entirety of the dog circle. Okay? This is the entirety of the cat circle. I apologize if my circle is not circular, but that's the entire circle of the cat circle. Now, the thing is, we also get people that only like cats but don't like dogs. This would be cats only. This would be dogs only. So we need to be able to figure out what the question wants because this is the people that like and. So I'm going to highlight stuff. This is the people that like and. We're going to say and. Right? In the exam, you might see it as A and B. But in this question, we see it as cats and dogs. This one, everything that's here, that's all of this, is or either. In the exam, you might see it as or either. You might see it as A or B. But in this question, it's cats or dog. So once we start to understand that, Venn diagrams become very easy, especially when there's unknown parts as well. So let's start, right? I will randomly give you guys this thing. We're going to deal with probability, not people. Okay? So we need to understand, even in the previous videos, there's a lot of algebra mistakes, but there's also a lot of mistakes where we read wrong. And that's what I did yesterday in the other videos as well, is where I misread the question. So double check everything. There's no questions here, but this is just teaching. So the probability of somebody who likes dogs. Now look at this. We need to understand if a person is in the center and they like dogs and cats, they do like dogs. So the probability of people that like dogs is 50 plus 20 over 100. And that's 70 over 100. And I'm going to leave it like that. I mean, 0.7 is what they really want, but it doesn't really matter. The probability, next one, the probability of people that like dogs only. Now, this is where it changes because they don't want the cats involved over there. So dogs only is 50 over 100, and that's 0.5. Okay. Now, I'll take this and I'll leave it one side just to make it a bit easier. Let's do the exact same thing. The probability of people that like cats is 10 plus 20 over 100, which is 0.3. The probability of people that like cats only is 10 out of 100, which is 0.3. Right, let's take that away. We don't need that anymore. Right? If we look at this, the probability of people that like cats and dogs. Now, cats and dogs are 20 out of 100, which is 0.2. The next one is the probability of people that like none. They don't like any animals, any cats or dogs. Maybe they like birds. 20 out of 100. Guys, that was just a joke. Please don't assume in probability. You're not allowed to. You have to take it there exactly as it was. I know this worked out the same. Please understand that the 20 came from here. It was just a coincidence because I randomly made up this question. Right? Now, guys, let's go to the more iffy stuff. Okay? This one is tricky, right? The probability of people that like cats or dogs. Now, I know I can look at the formula and I can say cats or dogs is 50 out of 100, or 50 plus 20 plus 10, because it's everybody that's here. And that's going to be 80 out of 100 or 0.8. But now this is the second formula that you need to write down. Unfortunately, it is difficult, but once you understand it, it's fine. Probability of A or B, that means cats or dogs, is equal to the probability of A, that's the total probability of A, plus the total probability of B, minus the probability of A and B. Now what's going to happen is we're going to take the probability of A, which was 0.7, or 70 over 100, whatever you want to use, plus the probability of the total circle of B of cats, which is 0.3, or 30 over 100, minus the probability of both A and B. Now, guys, this formula might be difficult for you guys, but you will get it, definitely. You'll start to memorize it after we practice. 0.7 plus 0.3 minus 0.2 equals to 0.8. And now you guys can see that these two answers just work out. Now, the probability formula is more important because most likely in level 4 questions, they will not give you the Venn diagram, but ask you rather to calculate. And the last one is the not. Now, the not is a problem because the not is, what is the probability? Let's say the probability of people that don't like cats. Remember, this is the, so I taught you there is ways to do it where we can count, or we can take total 1 minus the probability of cats. And you and I know the probability of cats was 30 over 100, so 0.3. So 70% of people don't like cats. And the truth is, this 20 also counts in that 70%. Because if we look at it, the people that don't like cats, we're going to remove cats. See, there's a cat circle. It's gone. And what's left over is the dog people only and the people that don't like anything. So that's what the probability of don't like cats ends up. Okay. There's one question I'd like to do before we move on. I'm just going to copy this. I'm going to put it here. I'm going to paste. And this question is annoying. But once you understand it, we are good. So I'm going to remove some stuff. The exam lessons that come up later on, you guys are going to see a lot of this there. And as long as we understand properly, Venn diagrams are very, very, very easy. Let's put 100. Let's take out the x. Okay. Let's take out the x. Now this is the exact same thing. Okay, so let's see. Okay, cool. Right. Now this is what most Venn diagrams are going to look like. Please pay attention. We have this Venn diagram of people that like dogs and cats. We interviewed 100 people, and X number of people told me they like dogs and cats. 20 people told me that they don't like cats and dogs. So this one was good. 100 people was good, and the X was good. Now, 70 people told me they like dogs. Now, this is tricky. And 30 people told me they like cats. Now, guys, whenever you'll see this, this is going to be tricky because they said 70 people like dogs. Did they say 70 people like dogs only? No, they didn't. Well, let's change this, right? Okay, cool. We can leave it. It's fine. 70 people like dogs. So this is the dog circle. So this whole circle is 70 people. So this part will be 70 minus x because we don't know what dogs only is. And 30 people like cats. So 30 minus x, and that would be the cat circle because we don't know what cats only is. We know that cats, people that like cats is 30. So it is complicated, but how do we solve for x? The way we solve for x is to take the total. 100 equals to, guys, I made this question up, so I apologize if the algebra is messed up. But we take the total 100 and you add everything in the circle. 70 minus x plus x plus 30 minus x plus 20. And we start to work on it. Now, the easy part is that the x and the plus x cancel out, the minus x and plus x. We start to add. 70 plus 30 is 100. 100 plus 20 is 120. And that's minus x. And that's 100 minus 120 equals to minus x. And now minus x equals to minus 20. And 20 equals to x. Okay? So what that means is I need to substitute. X was 20. We know that from the previous question. 30 minus 20 is 10. And 70 minus 20 is 50. Okay? Guys, all of the extra classes that your school offers, please go for it. If your teachers are willing to put in extra effort to help you guys, make sure to go. It's also their breaks as well. So if they're willing to do it. Some of you have messaged me to let me know that your teachers are willing to help you extra. Please do it. Education is important, so we need to make sure we take all the help we can get. Now, guys, we're going to start with this question. It says 500 car owners were asked what they filled their petrol tanks with, diesel or petrol. I already know this is zero because there's no car that I know that fills diesel and petrol into their car. If there is, I'm sorry, I don't know that. But given below is a Venn diagram that represents the situation. Calculate the value of X. Now, the total number of people interviewed was 500 people. So we're going to go with 500 people equals to 152 plus X plus 348. If we add this up, it's 500 plus X, and that's 500. And 500 minus 500 equals to X, and X equals to 0. And that makes sense. Why? Because cars can't use petrol and diesel at the same time. 4B, what can we say about the relationship between petrol and diesel? Now, we didn't get to this as yet. We will in the next lesson with identities and relationships. But this is called mutually exclusive. Now, mutually exclusive means that PA and B equals to 0. What does this mean? That means it's absolutely impossible for the two events to happen at the same time. You cannot turn left and right at the same time. You cannot fill diesel and petrol and expect your car to work. You can't, this means it can't happen. So technically, mutually exclusive looks something like that because the circles will never touch. So this diagram, I don't like it because the circles are overlapping, but the fact that it's 0 is fine. But mutually exclusive circles do not touch because it is absolutely impossible for A and B to happen at the same time. What is the probability of choosing a car that doesn't use diesel? Now, guys, this is probability of not diesel. We learned this previously, and this is okay. But it's let's do it properly. No, probability of not diesel is equal to 1 minus the probability of diesel, right? Because it's the petrol. So it's 1 minus, and the probability of diesel is 152 over 500. And this will definitely give you 348 out of 500. Why? Because the probability of not diesel is petrol. But sometimes it's not going to be as easy as this. So learn this formula. Okay. Question D. The probability of choosing a car that uses either petrol or diesel. Now, probability of A or B, we know this formula already, is equal to the probability of A plus the probability of B minus the probability of A and B. But technically, we know it's 100% because cars have to use petrol or diesel. This was created like in 2008. So I don't think electric cars were there at that point. Now the circle could be a little bit different with the electric cars. But for now, probability of A, we can go with 152 over 500. I'm writing 300, but 500. Plus the probability of B, 348 over 500. Minus the probability of both, which is 0. And that should equal to 500 over 500, which equals to 1. That would be the total. And what is the probability of choosing a car that uses petrol and diesel? Automatically, 0. Cars can't use both because it is 0. But we're going to end our lesson on this part. This is part 1 of the video. Part 2 is going to deal with mutually exclusive and is going to deal with identities. We'll do 2 exam lessons and we should be good.